Hello students, I am going to discuss today a new point, concentration and different ways to express concentration of solutions. So in this video we are going to focus on what is concentration and which are the different ways to express concentrations of the solutions. The video is useful to 12th science students, engineering students, pharmacy, BSc students, as well as chemists who are working in the laboratory. What is concentration? The concentration of the solution is defined as the relative amount of solute present in solution. It is a macroscopic property, can be expressed in a variety of ways, such as qualitatively or quantitatively. Then if you have to express it qualitatively, we are going to express it in two ways, dilute and concentration. So when a solution that contains a small portion of a solute relative to solvent, we are going to call it as a dilute, and a solution that contains a larger portion of solute relative to solvent, we normally call it as a concentrated solution. And semi-quantitatively, if you have to express concentration, then it can be expressed as unsaturated and saturated. Unsaturated, a solution in which more solute will dissolve. Saturated, a solution in which no more solute will dissolve. And quantitatively, there are a number of ways to express the relative amounts of the solute and solvent in a solution. That ways we are going to discuss today. One note we have to take into consideration that some expression for concentration are temperature dependent. That is, the concentration of the solution changes as the temperature changes, whereas others are not. So now one by one we are going to discuss the various ways by which we can express the concentrations of solutions. First one, percentage by weight, W by W percent. It is defined as the amount of solute present in 100 gram of solution. It has no unit and denoted by symbol W by W percent. If you have to write its formula, it can be written as W divided by W percent is equal to mass of solute divided by mass of solution into 100. By taking an example, we can discuss this. So as an example, consider 5 gram sugar dissolved in 20 gram of water. What is the weight by weight percent concentration of sugar in this solution? So for this, if you have to write the answer, we are going to write it as W by W percent is equal to mass of solute divided by mass of solution into 100. Then we have to put these values, that 5 divided by 20 into 100, we will get 25% as a weight by weight percent for the given example. So this is the first way by which we can express the concentration of the solution. Then second way, percentage by volume. So V by V percent. It is defined as the volume of solute present in 100 ml of solution. It has no unit and denoted by symbol V by V percent. Again, if you have to write the formula, V by V percent is equal to volume of solute divided by volume of solution into 100. Example, determine the volume by volume percent solution made by combining 25 ml of ethanol with enough water to produce 200 ml of solution. Answer. Again we are going to write the formula, then we have to place the values, that V by V percent is equal to volume of solute divided by volume of solution into 100. V by V percent is equal to 25 divided by 200 into 100. Then we will get 12.5% as volume by volume percent for the given example. So this is the second way by which we can express the concentration of the solutions. Then next, third way, weight by volume percent. It is defined as the amount of solute present in 100 ml of solution. Then W, weight by V percent, weight of solute divided by volume of solution into 100. Example, as an example, consider 27 gram of sugar dissolved in a 700 ml of water. What is the weight by volume percent concentration of the sugar in the solution? So answer, we are going to write again formula. Weight by volume percent is equal to weight of solute divided by volume of solution into 100. Then place the values, that 27 divided by 700 into 100, 3.85% is the weight by volume percentage for the given example. So this is the third way by which we can express the concentrations of the solutions. Then fourth way, mole fraction. It is denoted by small x. So it is the ratio, mole fraction, it is the ratio of the number of moles of that component and the total number of moles of all the components of the solution. It has no unit and denoted by a symbol x. We have to understand this, that how the ratio of the number of moles of that component and the total number of moles of all the components of the solution we are going to consider. But before this, one more term we have to take into account, that is what is 1 mole of substance. The amount of substance whose weight in grams is numerically equal to the molecular weight of the substance is known as a 1 gram molecule or 1 mole of substance. This term we have to use for a binary solution. If N1 and N2 are the number of moles of solute and solvent respectively present in the solution, then the mole fractions are given by the equations. Mole fraction of solute X1 is equal to N1 divided by N1 plus N2. Here N1 is the number of moles of solute divided by N1 plus N2, number of moles of solute and number of moles of the solvent. Similarly, mole fraction of the solvent X2 is equal to N2 divided by N1 plus N2. Further, the sum of mole fractions of solute and solvent is equal to 1. So that is X1 plus X2 if you are going to make, then that is always equal to 1. So this also we have to take into account. By this, if you are going to solve a problem based on the mole fraction, then we can consider as an example what are the mole fraction of the components of the solution formed when 92 gram of glycerol is mixed with 90 gram of water. Molecular weight of water 18, molecular weight of glycerol 92. Solution, moles of water if you are going to calculate, then it can be calculated as 90 gram into 1 mole divided by 18, which is equal to 5 mole of water. And moles of glycerol N1 we are going to calculate as a 92 into 1 mole divided by 92 gram of, which is equal to 1 mole of glycerol. Then next, mole fraction of glycerol X1 N1 divided by N1 plus N2. 1 divided by 5 plus 1, which is equal to 0.167 mole. And mole fraction of water X2 is equal to N2 divided by N1 plus N2, which is equal to 5 divided by 5 plus 1, which is equal to 0.833 mole. Again, we can add it into each other, that is X1 plus X2, we will get answer as a 1. So in this way, mole fraction is another way by which we can express the concentration of solutions. Then next one, molarity, which is denoted by capital M. What is molarity? Molarity of any solution is number of moles of solute per liter of solution. It is denoted by capital M and its unit is mole per liter. Molarity, we can write its formula as molarity M is equal to number of moles of solute divided by volume of solvent in liter. Example, what is the molarity of solution containing 0.32 moles of NaCl in 3.4 liters? Solution, molarity of solution calculated using again the same formula, that number of moles of solute divided by volume of solvent in liter. Number of moles here in this case 0.32, divided by volume of solvent in liter, 3.4. So we will get molarity for the given solution 0.094 molar of NaCl. Then next one, molality, which is denoted by small m. Molality of any solution is represented as the number of moles of solute present per kg of solvent. So we are going to write its formula as molality M is equal to number of moles of solute divided by mass of solvent in kg. Example, what is the molality of solution containing 0.46 mole of solute in 2 kg of water? Again, molality of solution M is equal to number of moles of solute divided by mass of solvent in kg. Then we are going to place the values 0.46 divided by 2.0. Molality M is equal to 0.23 mole per kg. So this is one more term by which we can express concentration of the solution. Then next one, normality, which is denoted by capital N. It is defined as the gram equivalent weight per liter of solution. Its unit is equivalent per liter. So equation, normality N is equal to number of gram equivalent weight of solute divided by volume of solution in liter. So how we are going to calculate number of gram equivalent weight of solute? Number of gram equivalent weight of solute is equal to mass of solute in gram divided by equivalent weight. Example, calculate the normality of 0.53 gram per 100 ml solution of Na2CO3 having molecular weight 106 gram per mole as the following reaction. Na2CO3 plus twice of H plus gives H2CO3 plus twice of Na plus. Solution, there are 2 sodium ions for each carbonate ion. So equivalent weight of Na2CO3 is equal to 106 divided by 2, which is equal to 53 gram per equivalent. Also 100 ml equals to 0.1 liter, as all we know that 1 ml is equal to 1 divided by 1000 liter. So VML, V divided by 1000 liter. 100 ml, 0.1 liter. Then normality N is equal to mass of solute in gram divided by equivalent weight divided by volume of solution in liter. Here 0.53 divided by 53 into 0.1, we will get the normality of the solution as a 0.1 normal. Then next, formality F. It is the number of formula weights of solute present per liter of the solution. Its unit is mole per liter. Formality, we are going to calculate by the formula F is equal to weight of solute in a gram divided by formula mass into 1000 divided by V in ml. Similarly, this concept is applicable to substances like NaCl, which dissociates into ions. Then one more point, that is dmol. D, it represents 1 mole of solute present in a 1 liter of solution at 0 degrees Celsius, and parts per million, that is ppm. It is defined as the parts of a component per million parts of the solution. It is widely used when a solute is present in a trace quantities. Thank you.